My name is Xavier Maldonado,
And I'm Jonathan Jones.
and the title of our project is using motion cameras to improve bicycle safety. And what we did was create a motion detecting camera using the Raspberry Pi in order to track bicycles that pass by the view of the camera.
So overall, once we finished the project, our main goal was to be able to improve the infrastructure bicyclists ride on, because every day they take a risk sharing a with motorists as like creating accidents or being hit by cars and such. So by taking all this data that we have, we plan to make roads safe for cyclists.
I'm Adriana Maldonado.
And I'm Jabbar Stassy, and the title of our project is using sensors to detect humans' arousal in order to conserve energy. And basically, we started our project by going to different different buildings across the campus. And we found out that in many rooms, the air conditioning and the light is on, even when no one is in the room, and that's wasting energy.
And so for the main purpose of our project is to be able to detect human motion within a room. Basically, with building the sensor, we are able to detect if it's a human insert or if it's a room with various sensors like pressure, temperature, humidity, air quality, I forgot the last one. And so basically we use Arduino to be able to do programming and all the various sensors.
Hello. My name is Markayla Reed. My name is Caitlin Jones. The purpose of our project was to, the purpose of our project was to test the efficiency and accuracy of the trilaterization of multiple Wi-Fi meters. Okay, so basically what we're doing here was, well, with GPS is accurate outside, but what if you need to find out where you need to go inside? So indoor positioning systems are still a new technology, but what we're doing is trying to make it more accurate so that, let's say you're like a freshman in college, and you're trying to find your classroom, and you don't know where to go. Of course you're lost, but you don't want to say, maybe you have too much pride, you don't want to tell anybody that you're lost. So you're trying to find it for yourself. With the indoor positioning system, you don't have to ask. You become more independent and you can find it on your own. This is a technology that's being used now in malls, in construction sites, in hospitals, anywhere public that you probably need to know where to go. Now it's a thing. So basically, we're trying to make it as accurate as possible, because since it's still a new technology, people are making new ways to make it more accurate, but it's also not cost efficient. It's very expensive to make it accurate. So we're finding out if we could test like Wi-Fi modules, and we can make it as accurate as possible using trilateralization, which is basically finding 3 access points and finding 1 coordinate point and see how accurate you can make it. So that's basically what our project is about, and yeah.
Hi, my name is Tatiana Maldonado.
My name is Spencer Ray.
And our project is we did graphite doped silicone force-resistive sensors. So basically, what we and our partner did, we tested various ratios of graphite doped silicone, and we mixed 2 solvents, naphtha, which is a gasoline, and silicone thinner in order to create the right ratio to make it an insole, a conductive rubber that can be used into an insole to detect footsteps.
The reason this project is important is I know that we have several athletes within this room, and while you're training, you may have insoles that you put in your shoes to track your training. And these insoles use single sensors that are casted inside of that insole. the insole that we would design would be, the insole itself would be a sensor, so it's more of a universal since everyone does not have the same foot. The implications of this can be, everlasting. They can be used for physical therapy, actual sports training, sports medicine, anything where you need to understand and analyze the structure and step pattern of your foot.